We're going to continue looking at the reactivity series, and in this lesson we're looking at the reaction of metals with oxygen. Now, in these photos you can see examples of different metals reacting with oxygen. And metals can react in two different ways. What we're seeing here are combustion reactions. That's to say, the metals are being heated in their various forms, and then they're reacting with oxygen in the air. Okay, so we've got sodium. That's producing that kind of yellowish coloured flame. And then we've got zinc dust. Then we've got iron, some iron wool. And then we've got some copper. That's copper powder. Now, before we discuss the various ways in which these metals react, let's just write out the general equation. And the general equation is really quite simple for metals and oxygen. So we just need to write the metal plus oxygen. And in each case what we're going to get is a metal oxide. Now, the speed and vigour with which this reaction takes place depends upon, again, the position in the reactivity series. Now, one thing we're going to say is that oxygen is a very reactive element indeed, and it will react vigorously with most of these metals. In fact, the only metals that it doesn't react with are silver and gold at the bottom of the table. Now, the energy or vigour with which the metals react with oxygen again depends upon their position in the reactivity series. So, for example, potassium and sodium here at the top of the table will react, releasing a lot of energy, and they will react quickly, whereas copper down at the bottom end of the table over here will react quite slowly. So in this case I've got the copper powder and I'm heating the copper slowly, but there's no actual ignition of the copper with the oxygen. So it slowly changes from the brown copper dust or copper powder into black copper oxide powder after 2 or 3 minutes of heating. Now, you can see these reactions if you go to the practical demo section on reactivity series and look at the reaction of metals with oxygen. Okay, so let's just take a specific example. For example, in the case of zinc, say. So we take zinc, write out the word equation first, plus oxygen produces zinc oxide. And zinc oxide is interesting stuff. You'll see this in the video. You'll notice that it changes colour as it gets hotter. So it goes through this kind of array of different colours as it heats up and then cools down again. So zinc oxide is known as a thermochromic substance. Right? It's something which will change colour as its temperature changes. And we want to write out the symbol equation. Then we write zinc, Zn, oxygen again is diatomic molecule. Don't forget that, and then zinc oxide, ZNO. We need to balance the equation. We've got 2 oxygens here, 1 here, we need to put a 2 here. And of course now we've got 2 zincs, so we need to put 2 zincs here. Like that, and the equation is now balanced. Now, the other way in which metals react with oxygen is through a process called tarnishing. And when tarnishing occurs, the metals react slowly with oxygen in the atmosphere. Now, this doesn't involve heating, it's just simply a direct reaction between the metal and the oxygen in the air around it. So again, the reactivity series plays a role. So the higher up the metal is in the reactivity series, the faster it will react with oxygen in the air. So here I've cut a slice through a piece of potassium, and immediately you'll see that the surface of the potassium is nice and shiny and clean. But within about 3 minutes, the potassium reacts with oxygen in the air and is soon covered with a layer of potassium oxide. Okay, so already within 3 minutes, the potassium tarnishes. Now, in the case of copper, which is down here at the bottom of the table, well, you'd expect the thing to be different. Now, here I've taken a copper kettle, I've cleaned it up so it's nice and shiny. Now, I've leave that copper kettle now for about 3 months, depending on exactly where you leave it, but slowly it will change colour, and you'll notice that it becomes darker as copper oxide, as a layer of copper oxide forms on the surface of the kettle as the copper metal reacts with oxygen in the air around it. Now this process, as I just mentioned, can take a much longer time than potassium. Potassium is done in 3 minutes. This may take, for example, between 3 to 6 months, okay, for the tarnishing to take place. So again, the position in the reactivity series is important. Now there's one more thing that I would like to mention, and that is that the equation for the reaction is exactly the same for tarnishing as it is for combustion or burning. So, as in both of these cases, you've got a metal, it's reacting with oxygen slowly through tarnishing, and it produces the metal oxide. So for example, in the case of copper, well, the copper, okay, we have oxygen, and that will produce copper oxide. And we'll want to write the symbol equation, and that gives us copper plus oxygen, O2, and copper oxide. And then, as with zinc and oxygen, well, we need to place a 2 here and a 2 here to balance the equation. So the equation for tarnishing and burning is the same. The only difference is that because we're heating it, in the case of combustion, the reaction takes place a lot faster. But the product is the same.